Good afternoon, everybody, and welcome to the third episode of the Dev Show. We notice a lot of new people on the page, so that's why I'm going to give you again a little bit of introduction of what the Dev Show is. So the Dev Show is your very favorite new weekly show, which on each of these show we are bringing one or two speakers. Sometimes we're going to have a panel, but we will have only one topic to discover, and we have a deep dive on this topic. And all of you are, doesn't matter if you're watching us via Twitch or via YouTube, you have an opportunity to ask your question from our guests. And how? By typing them on the chat. So again, I'm reminding you that doesn't matter if you're on Twitch or on YouTube, we get all of your questions, and then during the question and answer session, we are asking them from the speakers. And I just noticed that I forgot to tell you what my name is. So my name is Sherry, and I'm your host together with my very good colleague, Rasmus Jack.
Hi.
And Rasmus, what do we have on the agenda for today?
Yeah, today, as you said, we not only have actually one speaker today, we have two speakers, and they're going to talk about the security development lifecycle methodology and DevSecOps. So really important topics and area to touch upon these days. So that's really amazing. Sherry, before I introduce the topics in more detail, is there anything that the audience can get after the show? I reckon that the other times you have promised something like a badge or something like that. Can that also be the case this time?
Yes. Since we are still in summer, the temperature is above 20. So we still have Danish summer. So all of you, at the end of the show, you can get one of our summer badges, the Azure Hero summer badges. For those of you that you don't know about this program, so it's a community program from Microsoft to the developer community, and we can give you like a token of appreciation for learning our technology, for using our technology, or you can even go a couple of extra miles by empowering others, by teaching them or doing some community activity. At the end of the show, I'm going to show you a QR code where you can scan it and then get your badge. And I'm going to tell you that how you can even get more of the different badges that we have.
Awesome.
So, who are our speakers, Rasmus?
Yeah, today we have two speakers. The first speaker on is Irina Kostina, and she's a technology advisor in Microsoft and have been working with different aspects of IT, including system administrators, as a software developer in startups and also with team management. As hobbies, she says that she likes different sports like rugby, and she's also doing cybersecurity for fun, such as CTF, Capture the Flag competitions. So really into also the topic that we're going to talk about today. Our other speaker is Magnus Stubman, and he's a security advisor from Infosec. Sorry, Magnus. And he's originally a full stack software engineer turned into security advisor with a focus on offensive cybersecurity, doing penetration testing and red teaming, fuzzing, physical intrusions, etc. So also really deep into the topic. In his spare time, he's research security bugs in open source software. So also contributing back to the community. So the topic in more details today, Irina and Magnus is gonna touch on Microsoft Security Development Lifecycle practices. Also teach you about what is DevSecOps, static and dynamic application security testing, and also how to do software development methodologies, how they will increase the security level detecting and handling vulnerabilities and dependencies in pragmatic ways, high-level principles that always increase the security level. So that was a long speech from my side, but it's going to be a very amazing topic to cover, and also super important in these days where security in the digital space is super important. Let me hand it over to Magnus and Irina. Welcome, and the stage is yours. Need to unmute.
Yes, thanks a lot for the introduction, and welcome everyone. So I'm not sure, dear host, could you tell me if the slides are being shared? Okay, yes. So I would like to start with a story from 2017, just to set a scene why security is so important, and specifically the security of the software we develop. There was basically a massive data breach from the company called Equifax, which resulted in leadership leaving and losses for more than $2 billion. And more than half of it, they just had to spend on upgrading the security after this incident. $700 million was just spent for investigations, and $500,000 to pay out to their consumers. That breach occurred because of the vulnerability in the software, Apache Struts. And trust me, I'm not blaming Apache here at all. In fact, it was Equifax's responsibility to apply the patch, which they have not done. Although that could have easily been a zero-day exploit, and then they wouldn't even have an ability to patch it. So, and I see actually many companies have an attitude like that first no one is going to hack them, or they think there is nothing to take from them, even though they were hacked. And I hope that this actually pictures the reality of what actually could happen. And in the contrast with another big company, which as well had a vulnerability in their software, a company, Starbucks, they also had a vulnerability in their software. It was SQL injection in the front end, and it allowed to query financial data from Dynamics on the backend. But thankfully, Starbucks actually cared about security, and they were part of the bug bounty program, and their losses were just $4,000. So my point here that in order to prevent this kind of incidents, like what happened to Equifax, we all need to work towards a secure future. Customers should patch their environment, and we, software developers, we should produce secure software. So with that, I would like to give a word to Magnus, who will talk more about the security development lifecycle. And Magnus, stage is yours.
On like the methodologies we use to develop software. A lot of the time, when I come in as a penetration tester to assess and test software, I usually call in at the end of a development lifecycle before the software is put into production, and that basically shows a flow like this. There's a lot of development going on, and then I'm called in, or a colleague of mine or a competitor called in to do a penetration test or source code review or some kind of testing to identify security issues, and then we'll find a number of issues, and then those will have to be fixed or accepted before the software is put into production. So this is pretty standard, and it basically applies to the waterfall methodology. As an alternative that we see from a bit more mature organizations would be to have a bit more of an agile mindset, and that would be to obviously start with some amount of development, but then pretty early call in security professionals like me or a colleague or competitor to do some smaller amount of testing, not test everything, but to focus on the latest changes from the last sprint or the last duration since I was last year. So this allows me to focus on the issues that the developers have just created. So what they're doing is top of mind. It's not something that they did long ago, and the discussions we can have then will be able to to influence the developers and the project lead in a way that they might be able to make some architectural differences up early. Yeah. And then, of course, with the typical approach, we don't really know how many security issues there will be until we actually tested it. So we don't really know the requirements for when we can go to production, because we don't know how much time it will take to fix the things that typically I or someone similar would find. So there's a pretty big unknown amount of time needed there, or just a big risk to accept. But with the agile approach, we typically see that the amount of things we find at the end is smaller, because we usually find them earlier. Yeah, needless to say, of course. But just because with the agile approach that typically I or someone like me would come in, doesn't mean that development can have to stop. Usually I can get my own test environment and do the testing there, which means that the development can go on while I test. This is typically not the case with the traditional waterfall-like approach, because I have to test the final version, which means that everything needs to be done, which means that nothing, or at least very, very little, can be done by the development team while I'm there. So this is also a clear benefit to the more agile approach of doing it, that you can parallelize at least to some extent. And then, of course, regardless of methodology, regardless of how you structure it, we see some organizations training their developers prior to the development even begins. So sending developers to secure coding trainings or security awareness courses to be able to heighten their awareness for typical software vulnerabilities, because patching these things are cheaper if you can do it before it's even put into production. So the earlier you find security issues and vulnerabilities, the earlier you can actually do something about it, and it's going to be much cheaper to fix it earlier than to do it later, for obvious reasons, as Irina just pointed out with the costs. So after things have been put into production, we all know that at some point in time there will be more development costs after we put into production. And usually, at least from my experience, and this might not apply to everyone, but usually the cost of maintaining software will increase over time as the requirements change, or the code base gets older, or the programming paradigm or methodologies develop. It will be more and more expensive. It requires more and more time to actually fix bugs, implement new features, or integrate with new systems, and so forth. So how can we combat this in a meaningful way to keep the development and maintenance costs as small as possible after we have pushed to production? And I think, and obviously this is a really, really hard case to solve for in a general way that would make sense for a lot of people. But I think software architects should ask themselves as early as possible, just asking this question yourself, how easy, hard is it to get rid of this solution? Obviously, when you're in development phase, you're thinking about what it will provide, what benefits it will add, and how it will contribute. But you should also take a step back and realize that at some point in time, it might be in 5, 10, 15 years, doesn't matter when, but at some point in time, this baby that we're creating, this awesome piece of software, at some point, it will have to be removed. It will have to be deprecated, at least at some point. And if that question is hard to answer, then it might be easier to ask yourself this: how easy is it to move the solution? So what exactly does that mean? But let's say that you have deployed it in one data center in an environment. Let's say, as a practical exercise or a theoretical exercise, how would we actually move this from one data center to a completely different new data center in some other continent? Just to get a feeling of how intertwined, how tangled is this software to other existing dependencies or third-party backends that we might be consuming. And why am I talking about this from a security perspective? That's obviously because the more complex code is, the less maintainable it is, the harder it's going to be to solve security issues when you find when security issues are found, and it's also going to be more complex for me to assess software products if it's less understandable, so to speak. But we'll get back to that later. So to summarize, Your mileage may vary. One size doesn't fit all. You have to think about it in specific senses for your project. At least that's my experience. And the waterfall approach, it might make the development more reliable because you know exactly what you test. At the end, you're testing one product. There will never be any small features that were not security tested, because it will be the final build that people like me are going to test. But the time that you're going to put it to production might not be as predictable, because if I find 30, 40, 50 issues, then that might affect it, obviously. And the opposite applies to the more agile approach, where it's more predictable, because presumably, at least that's the experience, we find less things later if we test periodically throughout the development. And obviously, training, that's a one-time cost, at least to some extent, because security evolves, ways to attack software evolves, and therefore developers should stay up to date. But at least the training principles that you learn during training, at least to my experience, are the same across stacks over time. So I think you should take a step back from this and just ask yourself, what exactly are our requirements, and then be realistic. I mean, what of this would actually work in your organization? Because usually when you hear talks like this, it's like it might be a bit theoretical, and you have to be a bit pragmatic about what actually works. And we'll get back to that as well later. Another thing that I think is very important for the software development lifecycle is to have a formal definition of when something is done. So if you have the task of developing some user story and implemented that in some specific feature, then when you're done, then when are you exactly done? Should it be in production, or should it be in testing? And what should have happened before you can formally move your user story to the done column of your Kanban board or whatever you're using? And I think something like this would make a lot of sense. I think there should be some kind of checklist that you have followed some standards. You have unit testing for all the functionality. You have at least some kind of documentation that fits into the way that your organization likes to document your code. And preferably also that your code has been reviewed by a colleague, preferably a senior colleague, if there's someone more senior than you, of course. And then also that the documentation is reviewed, not just the source code, because the documentation is usually what people use first when they try to understand your code. And then at least from my perspective, one of the really important aspects of this is to have some kind of tooling to check if there's any vulnerabilities in third-party dependencies or libraries that you include. And one example of such a tool is the tool from OWASP called Dependency Check. So Dependency Check is a free software from OWASP, as I mentioned. It's a tool that will you just run it against your code base, and it will give you a report looking like this. This is just an example. So here we can see a list of third-party dependencies in the project that was scanned by Dependency Check. And as you can see, there's quite a long list. And if you look in the columns, the column on the right, you will see that the severity or the impact or the risk, or whatever you want to call it, from the vulnerabilities in the third-party software. To dig into one of these, if you click on one of these in the report, you will see something like this. So this is actually an example of Apache struts. If you recall, Irina mentioned Apache struts earlier today. So in this example, the dependency that was in this code base was Apache struts, and it was a version before 2.3.1.1, as you can see on the first line. And that is known to be vulnerable to this vulnerability that can allow attackers to execute arbitrary commands via a crafted HTTP cookie header that can trigger Java code execution. And there's even a link here to exploitdb that contains a valid exploit that could have at least theoretically been used. Because the thing is here that just because a dependency checker reports that you have a dependency that is vulnerable doesn't necessarily mean that that your software uses the vulnerable functionality. You might include the dependency, but then just not use it. Or you might use parts of it, but not the vulnerable parts. So you shouldn't take this as the holy grail that this is actually something that affects you. You have to take it for what it is. It is just a tool producing a report, and review it. Make a human being that knows these things review it for it to make sense. Then I'd like to take a step back and be a bit less technical, because usually for some organizations, when they hear about security issues or when they face massive challenges, it might pretty easily come up this discussion about, are we going to do it or are we going to not do it? Are we going to fix it or we're just going to let it be and accept the risk? So usually some people have this mindset of all or nothing when it comes to security. Either we have to do this and that and all of these things and really fix the issues, or we just accept the risk because we haven't been hacked yet, or at least you haven't found out that you've been hacked yet. And I think this is a very, very destructive way of thinking about it. It might make sense, but at least in my experience, that's seldom the case. Some of the arguments might be that security is expensive, it's going to hit productivity, it might hit performance, or fixing one security issue might actually open up some other security issue. So it might be that you have to pick and choose between which vulnerability you want to be affected as. And you might also have heard some horror stories. So I think this is an unfortunate mindset. And some people might even ask you that your only real viable solution is to scrap the entire code base and start over. But I think that the most important thing you can do if you have a massive security issue, it is just to do something. Get the snowball rolling. Take the first step. Just by doing some tiny things, it will open new ways of thinking and new doors and help and move it around. In my experience, at least, just working with a problem, although you might not have a good fix, just trying with some kinds of fixes will actually be helpful long term, even though it might seem counterintuitive at first. Yeah. And then I'd like to talk a bit about some security principles that I think always works for, not always, but in 99% of cases, it usually brings some kind of added security benefit, so-called silver bullets, or what you want to call it. So the first one is that usually, if you have one environment or one set of assets, we see sometimes that those assets or valuable, whatever it might be, are protected with the same key. So this means that if a red teamer or someone like me comes out and grabs that key, then obviously we can access everything that was protected by that key. So in order to solve this problem, it's pretty straightforward actually. Just separating the assets into subcategories, separating it into subgroups, and then give it one key each. Because then if I get one of the keys, I will only be able to compromise one of these categories. So that might reduce the security impact of a security issue. So this is a matter of segmenting, and it can apply to software development, can apply to Active Directory, can apply to networking, can apply to passwords, obviously, and so many different critical security principles. Segment, isolate, and separate. So next up, I'd like to talk a bit about talking a bit about code, because usually, I mean, let's be honest, code is hard to write, right? Over time, software stacks become harder to maintain, and it might be, as you see on the right, it might be a spaghetti, completely tangled, hard to separate. And usually, in my experience, one principle that always increases security is simplicity. It might sound simple, but having simple projects, having simple stacks, having simple ways of doing things might long-term increase the security level of the software project. So I'm not sure how many of the audience that are familiar with this code base, but I can promise you that I think it's very few people who can honestly say that they understand everything that goes on here. This code sample is from the pretty famous security tool called Mimikatz, and I think very few people really understand everything in Mimikatz by heart. So in contrast, I guess a lot of people will understand this. Obviously, this isn't real code, but it's just to show you that if you consciously program for your code to be more readable and simple and easy to understand, then long term that might be a huge security benefit. Because as I mentioned earlier, when organizations hire pen testers or security analysts to come and inspect the code, it will be much easier for me to do my job if it's easier for me to read. And that in return will make me able to find more security issues, which will increase the value for the organization, because less issues will be unnoticed. So complex code, to summarize, complex code is hard to read, it's hard to review, and it's hard to maintain, because I guess very few people will actually remember all lines in a software project, if none at all. And it will be hard to add new features, and it will be hard to remove it or replace the software project if it's not completely well understood by the time it needs to be deprecated. And needless to say, developers working on the solutions will presumably experience and be less satisfied with the development that they're tasked with, and it will be harder for me to pen test, and obviously it will be more expensive. So for those sakes, simplicity is highly underrated, I think. So earlier I talked a bit about security as something that you think about and talk about, and I'd like to address it as a bit of a cultural phenomenon, so to speak, because security is, at least the way I think about it, it's treated way differently by management and when as compared to software developers or administrators. So the classic approach, of course, to try to bake in security in an organization as to make it a part of the DNA and part of the culture, is to apply policies and guidelines. And we all know them, that your password must be this long, or never leave your computer unlocked, or never connect to Wi-Fi in airports or hotels, and similar issues. So this is what we call the top-down approach, that security is applied from the top, and it's supposed to drip down in the organization and improve the security level this way. And don't get me wrong, it's definitely a good way to do it. But there's also another way to do it, which I think sometimes are forgotten, and I think is underrated. And that is to do the opposite, the bottom-up approach. And that would be to apply more security awareness training. So train the employees, train the developers, give them formal training in writing secure code and how to think about code. Doing it this way, people will start talking more about security, talk more about how to make things in a secure fashion, and that will improve the security like bottom up, like nourish inside the organization. So obviously both is best. Another way to do it, to be a bit more concrete, would be to, for example, let's say that the organization hires a pen tester to come and do a pen test. Then I suggest that organizations like gather the developers and just go through the pen test report with them, and don't point any fingers. It doesn't matter who introduced the vulnerability, but talk about what exactly was found here, how would you exploit it, and what are the different pros and cons of mitigating it in different ways. Doing it this way, everybody will learn, and going forward, I think, would be a more secure development team. Yeah. And obviously, whenever a new feature is discussed, or whenever a new feature is implemented, or whenever something is done, then ask yourself, what are we doing to prevent this from being abused or exploited? I think that's maybe one of the most important takeaways, at least from my part today, is to ask yourself, whenever you're looking at something like how could I or someone else misuse this? Go into the mindset of the attacker, within reasons, of course. I mentioned the dependency check tool. Dependency check was created by OWASP, and OWASP has a really decent top 10 project going on, where they categorize the top 10 most common security issues that they experience and highlight these. Here you'll see an example. The first one is injection, broken authentication, and so forth. I'm not going to go through all of these, but this is just to show you that the OWASP top 10 project could be something that you could bring up on your next team meeting, or maybe assign one category each, and then for the next Friday lunch or whatever, you present it for your teammates, so that you would have more like case studies to better learn and go in depth and maybe be familiarized with some of these categories that you maybe haven't heard about before. Yeah, so summarizing the silver bullets, I think segmentation is probably the strongest, at least one of the strongest principles to employ. Simplicity, keeping it simple, making it easy to understand, and then of course at least have some notion about how do we as an organization treat security as a cultural phenomenon. I mean, do we care about it? Do we talk about it, and so forth? I think if you want to start somewhere, I would suggest you start with these very, very simple principles and see how it would work for you. And with that, I guess I'm giving the word over to Irina, and thank you.
Thank you. So I would like to talk actually about the Microsoft practices and specifically about Microsoft Security Development Lifecycle, which is a methodology which was born inside the organization. And it is actually what we use these days to write more secure code and products. This is basically a number of practices which were born inside the organization and put into best practices. Some of them are not very technical and they are not related to exactly how do you write the code, but more how do you function as a team, what kind of standards you have defined for cryptography, and which third-party components are allowed to be used. So I would like to focus today more on the practices which I found more relevant for developers. But I think it's important to go through quickly all of the existing practices. And if we have a look, for example, number one, provide training. It's also what Magnus was talking about. It's basically about creating awareness that security is important and make sure that everyone actually understands what are the practices there and know how to build secure software and products. So security is essentially everyone's job, and it's important to remember that not everybody has to be a security expert or penetration tester, but ensuring that everybody understands the attacker perspective and goals will actually help to raise the collective knowledge bar. There are also practices about defining security requirements or establishing design requirements. This is about the need to consider security and privacy as a fundamental aspect of developing secure software, with regardless which methodology you're using. Security requirements, they must be constantly updated and reflects changes in functionality, and ideally should be defined early in the process. You also need to define metrics, basically that again builds on top what Magnus was talking about, the definition of done. It's essential to define the minimum acceptable levels of security quality and strive for that criteria. You can also configure that in tools. For example, in Azure DevOps, you can specify that. You can specify the security for your security properties for your work items, so that later on you will be able to track what's the severity of it and also provide some reporting. So practice which I think related to software development is to perform threat modeling, and I will talk about it more in detail later on. Of course, it's important to define and use cryptography standards, and if you take a course about cryptography, the very first thing which is said there, do not invent your own algorithm or protocol, because it's actually quite a complicated thing to do, and if you make a mistake there, it might have quite catastrophic coincidences. It is important to manage the security and risk of third-party components, which is basically what Equifax failed to implement with that vulnerability in Apache Struts. So consider infusing, for example, dependency check, which Magnus was showcasing, or there's plenty of other tools. Like, for example, there is DependBot in GitHub, which is a free tool to check vulnerabilities and dependencies of your software. So another practices which I find really relevant for developers is to perform code analysis. There is two types, static and dynamic. And again, I will go more into details about that. And of course, it is important to perform penetration testing. Penetration testing is basically security analysis of the software performed by someone who's simulating actions of a hacker. So the objective is to uncover potential vulnerabilities coming from code errors or some misconfiguration or perhaps operational or deployment weaknesses. So the report which I referred in the beginning when I was talking about Starbucks, the report from HackerOne, it's basically a bug bounty program, which also pen testing can be a form of bug bounty programs. And a lot of big companies are doing that. It's different from just hiring one because it's a free platform and it has a lot of good professionals there. So I can recommend resources such as HackerOne or BugCrowd because they have a lot of good security professionals in them. And the last practice is to establish a incident response process in the organization. It's basically meaning that it's important to have a plan to address the threats when they are arising. Usually big companies, they have a dedicated team for that, or I hope that they have a dedicated team for that. And of course, if you're a small company, this can be done by one or two persons. The plan should include basically who to contact in case of security emergency and establish the protocol, including the plan for the code, also inherited from other groups of organization or some third-party components. And of course, it's important that incident response plan is actually tested before it is needed. So now I would like to go deeper in some of the practices. And the first one is threat modeling. So basically, it's used on the development stage, and there are 5 major steps in this process. First of all, you need to define security requirements. After that, you need to create an application architectural diagram. Then you identify threats, mitigate them, and making sure you validate that threats have been mitigated. So Microsoft has a free tool for that, and it allows software architects to identify and mitigate potential security issues earlier when they're relatively easy and cost-effective to resolve. So as a result of that, it reduces the total cost of the development. Also, we designed this tool with non-security experts in mind, making threat modeling easier for developers and providing actually clear guidance on creating and analyzing threat modeling. So I will quickly show this tool. So you can download it from actually use an existing one. So as a first step, we're supposed to create an architectural diagram of our application. And as we can see here, I already have it, and it consists of different components, such as API. Also, we have web application here, database, app insights, log analytics, Active Directory, and so on. This tool has plenty of already made components in it, related to Azure, but not necessarily. It also has generic ones and production and something from on-premise as well. So after we have done the architecture, and we also need to specify the trust boundaries of our system, then we can perform an analysis of our system by pressing Analysis View from the menu. And then it will actually generate a list of threats based on the default template which we have in SDL approach, meaning that we have it's called Stride, and it's using the category one of the 6, meaning that pretty much every threat will be falling down in one of these categories. So if we have a look at one of the potential threats which it found, for example, we can see that we can see, of course, the state that no one actually picked it up yet or modified anything. We can see the category which was assigned to the threat, and we can also see where exactly in our system it might occur, because it highlights it in the diagram. So it's actually quite handy if you have a big and complex environment with many components. And in description, we can see actually what exactly that threat is about, and what potentially which potential harm it could do in our environment. So this tool ideally should be part of the routine of the development lifecycle, and it is important and actually cheaper to mitigate threats earlier in the process. And it's often, you can hear that these days security is shifting left. And what it actually means, that in traditional development process, you will identify security issues, hopefully, on operational stage. And in many cases, it is most likely going to happen when it's already in production and used by customers. So what we would like to achieve is basically to identify those effects early as possible, and preferably in the development stage when we actually have the flexibility to change things. General DevOps approach has introduced processes like continuous integration and continuous delivery. And these processes ensure the active testing and verification of the code. So DevOps has replaced siloed development and operations and created multidisciplinary teams which are working together with shared and efficient practices and tools. And similarly, DevSecOps, it injects active security audits and penetration testing and other processes into the agile development. With DevSecOps, it advocates that security should be built into the product rather than applied to a finished product. So nowadays, with the mindset shifting to DevSecOps, it includes an important thinking about not only preventing breaches, but also assuming breaches as well. That means that you have to assume the worst, that you'll be hacked no matter what if someone actually wants to. And the truth is, it is actually harder to defend than attack, because in order to hack someone, you actually just need one misconfiguration or one vulnerability. Although to defend everything, you need to check all of your environments and to make sure that everything is secure. So what can we do for that is basically, in order to prevent majority of the breaches early in the process, so we can perform certain practices, like, for example, code scanning, and also scanning of the environment and infrastructure or application level. Perform penetration testing, threat modeling, dependency checking, so that in that way we can provide feedback with the fast feedback loop earlier in the process when we actually have resources to fix it earlier. Another thing, when we're talking about DevSecOps, it is actually important to secure the DevOps environment itself and development environment and infrastructure around it. So I would like to quickly show a demo for Azure DevOps, how you can keep track of that in your environment. So we have a toolkit, a secure DevOps kit for Azure. It's basically a collection of scripts, tools and extensions which can be used by DevOps teams, and it integrates security into DevOps workflows and help to accomplish secure DevOps with different focus areas such as subscription or CI/CD, cloud risk governance, and so on. So I want to emphasize that this does not scan the code in repositories. Instead, it's actually focused on a set of permissions and access privileges in your environment. So in order to configure that in your Azure DevOps, you need to modify the pipeline. So if I go to my pipeline and I click Edit, you will be able to see right now that I actually already have it configured. So essentially, it is just an additional job which you have to integrate into your pipeline. It's called ADA Security Scanner. When you're adding it, you have to configure certain settings for it, such as name, or you have to specify connection to the Azure DevOps instance, organization, settings for the projects, and so on. So once you have done that, you will be able to access an automatically generated dashboard. It's called Security Scanner Summary, Security View. So it basically has a predefined list of the things it's checking. Again, it's focusing not on the scanning of the code, but it's focusing on the set of permissions you have in your environment, such as permissions for the pipelines, boards, connectors, and so on. And then it generates these reports. It's broken down into sections, and it's easy to understand actually where exactly you might have some misconfiguration or provided too many privileges. It also generates a report for organization itself and for the projects. So the next thing I would like to zoom in is the code scanning tools. There are two major categories for that. The first category is static testing, and with this kind of testing, can take place during the development phase, and it can be integrated into continuous integration process easily. So it gives real-time feedback, helping you fix issues before they actually go into the next phase of the development. And it's actually very handy to use them because it actually highlights where exactly in the code vulnerability occurs, precise lines, and sometimes also some of the tools can explain how to fix those. There are a number of pros and cons for these tools. So it scales well because you can apply it to majority of the languages, and it's a good thing that it actually finds vulnerabilities early in the process, because then we don't have wait for next stages of development to receive the feedback. So in this way, we actually perform development faster. And as I mentioned before, it highlights precise source files and the line where the vulnerability occurs. So some of the vulnerabilities, it doesn't cover, it will not find everything in all vulnerabilities in your application. So some of the things it's actually quite hard to find with this kind of tools. And if you will try to use them, you will see that actually it produces quite high number of false positives. And it's also sometimes hard to prove that that is an actual vulnerability to your software. But it is getting better with time. And it cannot find many vulnerabilities such as misconfiguration because it is not presented in the code. So quick demo of what could be used and easily integrated again. Maybe perhaps some of you heard of SonarQube. But there is an even better thing. It's Sonar Cloud. It's a software as a service product for code scanning. So let's take an example of Gmeter, which is an open source tool, and they have configured Sonar Cloud to analyze the code periodically. Perhaps maybe with each build, which commit with a new commit on the source code, they are executing this code scan, and automatically that is producing the report about the code with the amount of bugs, unit tests coverage, and so on, but also vulnerabilities. And we can see here what kind of vulnerabilities it found, for example, for Gmeter. We can see here that it actually provides a reason why it is in a vulnerability, a description of it, and potentially what kind of payload could be used in order to exploit it. We can also see that it assigned some category to it when it was first time discovered. That was a long time ago, 15 years ago. But potentially how much time it's going to fix. So no one found 15 minutes, 15 years to fix it. And as I mentioned before, it highlights where exactly the vulnerability occurs in the code. You could also configure a similar thing in GitHub. That feature is currently in the preview. It's called Security Code Alerts. When you apply to that beta feature and you're approved, you have to configure GitHub action for that in your pipelines, and after that, it will generate the list of alerts. And it looks similar to what we just seen with the Sonar Cloud. We can see, for example, that it found some cross-site forgery issue or code injection. Also, hard-coded credentials. For some reason, it's just a warning, but I think it's pretty severe thing. So again, we can see where exactly it's occurring, and more information about what is this vulnerability and what potential harm it could do. So another type of the code scanning tools is dynamic application security testing. It's basically testing an application in a running state. So, for example, Dest can test all HTTP and HTML access points and emulate random actions that emulate user behavior to find vulnerabilities. So because it doesn't have access to application source code, it detects security vulnerabilities by attacking the application externally. So it doesn't look at the code like static tools do, so it cannot point out where exactly in the code vulnerabilities occur. So for the sake of time, I actually have to stop right now because we'll have only 3 minutes left. So I think I will give the word to our hosts now. Because anyway, it was mostly end of my presentation.
So thanks for this really great presentation, both Irina and Magnus. If the audience, they are really keen on asking the questions that they didn't put into the chat today, is there anywhere that they can reach out to you guys on Twitter or something like that? So ladies first. Irina, would you want to go first?
Yeah, absolutely. I think LinkedIn would be the easiest way, and I'm pretty open to not only questions about this, but anything Asia related.
Okay, that sounds really good. So that's an open invitation to ask questions about Asia to Irina on LinkedIn. That's generous. What about you, Magnus? How can we find you?
Yeah, I think Twitter would probably be the most straightforward. LinkedIn is fine as well, but Twitter is usually the fastest.
Yeah, what is your Twitter handle then?
Just my Magnus Stubman in one word.
Okay, super great. So as I said, there's no questions in the chat right now. So I just want to everybody to give a virtual applause to Magnus and Irina. Really great presentation. It's been a pleasure for also me to listen in, and then I'm just gonna hand over to myself because Sherry is not here anymore for this stream. So I will just open the presentation here. 1 second. So we need your feedback. Basically, as I always say, we want to improve this show. We want to make sure that that we get the content that you like as an audience. So please go in and give your feedback. Also, if you want to be the speaker, if you have a topic that you want to share in one of the upcoming episodes, please go in and share your topic in the feedback form as well. And we also would like, of course, feedback in terms of how we run the show, and so we can improve. This is your show. As Sherry promised you in the beginning, you will be able to get a Summer Learner badge for this episode as well. So go in and claim your Summer Learner badge. Both the QR code for this Summer Learner badge and also the feedback form will be shared with you afterwards in the follow-up email. But you will be able to claim the Summer Learner badge by having been part of this session. If you want to learn more about the badges and what you can use them for, and also the Azure Heroes program that Sherry talked about in the beginning, please go to aka.ms/azure.heroes, and you will be able to learn much more about the program in there. In terms of what we have up next, in this show, we have next week Infrastructure as Code with Simon. So I really look personally forward to that. Simona, I really look personally look forward to that topic as well. It's going to be amazing. And if you look to the cloud secrets, you can also learn about cloud migration stories, as you also heard in the last episode. We will have in the Dev Show Hero Bot Builder with Chanel. So going a bit outside of the security and Azure area here, but talking about the Hero Bot Builder. Also, NG Copenhagen, the 9th of September, you will have an online webcast there. And finally, for the September 15th Dev Show, we will go into depth with the object detection with the Python and Azure Custom Vision with the Goran. Also really important and an interesting topic. So if you don't already have signed up for and registered for those sessions, please go in and do it, and hope to see you for the next one. If you have feedback other than what's in the feedback form, please reach out to Sherry or myself. You can do it on Twitter. It's also okay on LinkedIn. And please go and follow us on Twitter with the 4devs and MSDevDK. With that, I'm gonna say thanks to Irina and Magnus once again, and then I'm just gonna say thanks to everybody listening in, and see you again next time. Bye bye.
Thank you.
Bye. Thank you.